Good afternoon. My name is Bovari Eagle Parson.
I'm Epiphany Jackson.
I'm Alexis Satchel.
And I'm Erin Hunter.
Today we're going to talk to you about fruit preservatives. I'm going to do a little bit of an introduction to fruit preservatives. Then Epiphany is going to talk about the chemistry of the jam. Alexis is going to talk about the food engineering aspects of the jam. And then Erin is going to talk about food microbiology, excuse me, from a spoilage point of view. And I'm going to talk about food microbiology from a safety point of view. And after that, we will conclude. Now, what are fruit preservatives? According to Title 21 of the Code of Federal Regulations, preservatives, also known as jams, are viscous, semi-solid foods with the common ingredients being fruits, saccharides, pectin in reasonable excess to the natural pectin present in the ingredients, and some form of acidifying agents. It has to be 47 to 55 parts by weight of fruit to saccharides, and it has to be contain more than 65% of soluble solids.
Okay, everyone, I will be talking about the food chemistry. And first, I would like to say that the food chemistry of jam has 3 key chemical entities, and that would be sugar, acid, and pectin. Okay, this, I'm sorry you can't see it well, it looks like you can. But it's just an overview of the different components, like I said before in the last slide, which is the sugar, the acid, and the pectin. So here is the sucrose, and at the end of your solution, you should have a 65 to 95% concentration of sugar. As far as the acid, the optimal pH for setting should be at least 2.8 to 3.3. And then, like I said before, that pectin is very important, so I'll go ahead and let you know that pectin is a carbohydrate made up of a large number of sugar molecules bounded together in a large chain. The amount of pectin that you get from your fruits just varies depending upon which fruits you are actually using. Here in this slide, I just show you a couple of fruits that actually have enough pectin to create the gel. Some that may need more pectin added into their solution to make it gel, and some fruits that will actually be watery if you do not add any pectin to create your gel. Here's how pectin works. There are 2 types of pectin. We have high methoxyl pectin, which has greater than half of the carboxyl group in the methyl ester form, and we have low methoxyl pectin, which is less than half of the carboxyl groups in the methyl ester forms. And this is a little bit more of how the pectin actually works. We use high methoxyl pectin in jams, and it forms spreadable gel in the presence of sugar and acid. So I'll go ahead and explain to you all how that works. So basically you have your fruit and the pectin is trapped inside of the fruit. The pectin that is in the fruit is negatively charged. So we mix all of the ingredients as far as the fruit, the sugar, and the acid, and then we heat we heat all of this up. And then the heat plus the acid breaks down the fruit and releases the pectin. Pectin is then fully hydrated, and the pH is now low, and the pectin solution is now more neutral. The pectin goes from highly hydrated to slightly hydrated because the water was already neutral. Now we have the polymer chain of the pectin that starts to intertwine and cool together. At this stage, they are able to trap the water and form a gel network. The sugar also being present competes for the water and ensures that the pectin isn't completely surrounded by water molecules. That ensures that pectin can attach to other pectin chains.
Okay, now we'll talk about the engineering of jam. This is a processing flow diagram for jam. As you can see, we're gonna start off with the raw materials. It's basically we'll have, the fruit imported from an outside source. Prior to using it, it will be, established that the fruit is okay to use and safe to use. But just in case, we go through a washing process, which basically just gets rid of any extra things that may be on the fruit, such as like soil or leaves or insects that may be inside of the fruit. Then we'll go through a chopping process. If you all are familiar with eating jam, they have, small pieces of actual fruit inside of them. It's not full concentration like solution that's solidified, has actual fruit in it. Then we'll go to the batching processes, which is basically the process in between of transporting all of the material to the mixing, which will add the dye for color if needed, pectin and sugar. Then from there, we'll move to the acid adding, and in this case, we're adding citric acid, and that's basically to add, to stabilize the pH value. Then we'll move on to the boiling process, and I'll talk about that a little further on. But the boiling process is one of the most important process during making jam. Then we'll go to filling, which is basically an automatic process through a manufacturer. There, depending on how much concentration you have for your jam and the size of your containers. Most jams are put in jars, so depending on that, the filling is set prior to, the machines are set prior to, so it'll know exactly how much to put in each jar. Then you have a fastening process, which will seal the lid on top of the container, which is typically done mechanically. Then you have a sterilization process, which will be talked about later on. It's not necessarily needed in the processing of jams, but it is used just to ensure extra safety for the jam. And then we'll have a cooling process, and then we'll go to storage prior to shipping out to the different companies that will be selling for consumption. Like I said before, boiling is a key step in the processing of jam. It helps concentrate the mixture, and by that it helps the total soluble solid must reach about 65% or greater, as Bodie said prior to. The sterilization is an in-container process, so it must be done for 25 minutes till it reaches 98 degrees Celsius. These are some equipment pieces that will be used throughout the process of making jam. A washer, like I said before, is basically where they go through and do extra cleaning of the fruit, which is basically used through water. We have a slicer and a chopper, which is basically the part of the machine that cuts up blades, basically that cuts up the fruit. Then you have the vacuum / pneumonic conveyors, and it's basically a pipe that utilizes air to take that's the suction that basically takes the jam or the mixture from one part to another part of the actual machine, which will go to the tanks or the processing vessel, which will basically be like just like a big bowl kind of. And then you have the retorts, which is basically in a sense of you can refer to it as like an autoclave. And then you have the packaging system, which is a manufacturing system, which is where they'll do like the filling and the fastening. Some critical control points that we have for jam would be washing. And during the washing process, you have physical and chemical components that you need to worry about. You have like foreign material, like I stated earlier, which would be soil that may have, still on the fruit, or if you have leaves and stuff that are still in the batch of fruit that's received. Then you have a sanitation solution, which can be a chemical contaminant. Just think about, at the end of each processing shift, you know, they clean off the machines and the material, and if they don't properly, clean off all the solution, that could possibly be a chemical contaminant to your product. For mixing, we also have physical and chemical contaminants that we will be worried about. Metal shards or shavings from the machinery that could possibly get into the mixture for the jam, which will ultimately can be harmful to you. Also, the sanitation solution plays a big part in mixing too for a chemical, because like I said before, if it's not properly clean and there's residue still left from the chemicals, it can get into the jam.
Okay, I'll be discussing the food microbiology food of jams. And jam is typically known as a low pH, high acidic food product. And it also, the acid in the product actually extracts the natural pectin, which aids in lowering the water activity. You also can have your food go through a dehydration process, which drives off the moisture, leaving the food stable, and helping to lower the water activity as well and the moisture content. And all of this inhibits microbial growth in the jams. Threats to jams are molds, and molds are able to thrive in saccharine environments, and they're also able to thrive in an environment with low pH. Even though it can thrive in those kind of environments, it is not able to live in a hermetically sealed environment because of the oxygen that the environment has, and lids also play a role in mold getting into your product. And some people actually use wax to seal their cans instead of just a regular can lid. And this is actually a bad thing, because what wax can do is wax can trap air between your wax and your jam, which inhibits mold growth. And wax can also crack, and the seal can be broken over time, which inhibits mold growth. The spoilage of mold includes flavor changes of your product, discoloration of your product. It produces mycotoxins with contaminated products, and it rots your products. And usually when your product is molded over, it has a fuzzy appearance on it, and it also has a musty type odor to it. A next threat to jams are yeast, and yeast are single cell organisms that can thrive in low pHs, and they can also grow in the presence of metabolized carbon sources. And the spoilage of those include they change the properties, the physical, chemical, and sensible properties of your food. And usually when you have yeast in your product, you will either smell a yeasty odor or kind of like alcoholic odor. One mold that can affect jam is aspergillus. It produces bread-like branching filaments. It also produces mycotoxins, and it produces a yellow, green, or black growth on the food product. The key in keeping your jam safe is the storage. It should be stored in a cold, dry environment of 50 to 70 degrees Fahrenheit. And it is recommended that you refrigerate your product after the seal is broken. And it's also recommended that it really depends on what product that you have, but with jams, they can be used up to 1 year. And if your product is low in sugar or has no sugar added, it tends to have a shorter shelf life. And these are just a few expiration dates. And as you can see, they vary within 1 to 2 months, 6 to 9 months, or a year.
I now be talking about food microbiology safety of jams. Now, in developing a HACCP plan with regards to biological contaminants, what you need to look at is the likelihood of occurrence and also the potential severity of the hazards. As such, we want to focus on pathogenic microbes. Then I pose the question, would there be biological contaminants in HACCP for jams? In order to answer that question, we need to look at some of the characteristics of jam. Throughout the processing of jam, there's almost like an automatic hurdle technology that is applied because A, we need the high heat of boiling during cooking simply to increase the soluble solid content. It also aids in extracting more of the natural pectin in the fruit. And most of the time, there's also an in-container processing afterwards with the sterilization in a retort of 98 degrees Celsius for 25 minutes. Now, jams are also low pH products with a pH ranging from 2.5 to 4.0. Jams are also referred to as intermediate moisture foods. That means that the water activity is about 90% due to the high sugar content, and the moisture content is about 10 to 40%. Now, I want to look at some ubiquitous microorganisms that could be a problem in fruit. And of course, fruit are agricultural commodities. So the two of the microorganisms that could potentially be problematic are Clostridium botulinum, which produces multiple toxins. And if you become intoxicated, it can induce vomiting, blurred vision, difficulty swallowing that progresses over time, and even respiratory failure. And it's a very serious condition because there's a 70% fatality rate. The other organism that we're looking at too is Listeria monocytogenes. And in adults, it can induce gastroenteritis, and in babies, meningitis, and also with pregnant women, it can induce the abortion of the fetus. Now, in order to see if these are problematic in jams, we're going to look at the minimal growth conditions for both of those organisms. So Clostridium botulinum actually has spores that can be found, or spores of Clostridium botulinum can be found in most foods. However, it needs a pH of at least 4.6 and a water activity of about 94% in order for those spores to germinate. Therefore, in jams, that would not be a problem because the pH is both lower and the water activity is lower. On top of that, the D value here is 100 degrees Celsius for 25 minutes, which is very close to the sterilization process described earlier. For Listeria monocytogenes, it is found in many agricultural commodities. And the minimal growth conditions for that are a pH of 4.6 and a water activity of about 92%. Now, those parameters also are higher than what is found in jam, but as if that weren't enough, the D value for that is only 60 degrees Celsius for about 5 minutes. So the boiling process of jam definitely takes care of that. Now, Aaron mentioned earlier that yeast and molds can also be problematic in jams, especially aspergillus or osmophilic yeast. However, since they relate to the quality of the product and not the safety, they are not really applicable to a HACCP plan. And with that, we would like to conclude that
Sugar, acid, and pectin are the major chemical entities in fruit preserves.
Washing and mixing are the CCPs for physical and chemical contaminants.
Mold and yeast are spoilage organisms of jams.
And biological CCPs for gems are non-existent due to the hurdle, automatic hurdle effect. And also, as you can see, for the engineering, soluble solids need to reach 65%.